Hello, good morning. Again, welcome to the Say Hi online training. This is day 3. Today is March 15, 2020, and our subject, internal combustion engine for the electromechanical course. Okay, we will have a topic for today. The topic is piston ring and gap clearance measurement. Before we proceed to our topic, we will have a short review. Okay? So, what are piston rings? Piston rings are metallic rings which are placed in the piston ring grooves designed to seal the gap between the piston and the cylinder wall. Let me show you the piston rings. Alright. Okay, another one on my left. So here are the piston rings. Okay. So there are two types of rings. You have compression rings and the oil control ring. And let me show you the piston. Okay. So where's that place where the piston rings are being placed? So here are the grooves which when you install the piston ring would stay. Okay? So again, piston rings are metallic rings which are placed in the piston ring grooves designed to seal the gap between the piston and cylinder. So we have understood that there is a gap between the piston and the cylinder wall. So the piston rings fill this gap or is designed to seal that gap. Okay? So question, what if that gap or this gap were small? Okay? If this gap were too small, thermal expansion of the piston could mean the piston seizes in the cylinder, causing serious damage to the engine. Okay? So, if there is a thermal expansion, that would mean metals will grow bigger, and if the gap is small, then the piston would seize or stop in the cylinder. What about if that gap would be large? Okay? So on the other hand, a large gap would cause insufficient sealing of the piston rings against the cylinder wall, resulting in excessive blow-by, combustion of gases entering the crankcase, and less pressure on the cylinder, reducing the power output of the engine. Okay? This means a large gap, okay, would permit a compression leakage. Okay? So when you say compression leakage, it's a blow-by. So combustion gases entering the crankcase. So the compression pressure or the compressed air would flow past the piston rings so that it would enter the crankcase. So instead, it would stay in the combustion chamber because of the large gap. The compressed air would leak out of the combustion chamber. So, as you already know, if you lost that compression pressure, it would result to a loss of power. So on those accounts, what are the main functions of the piston rings in the engine? Okay, number one, sealing the combustion chamber so that there is minimal loss of gases to the crankcase. And number 2, improving heat transfer from the piston to the cylinder wall. Number 3, maintaining the proper quantity of oil between the piston and cylinder wall, and regulating engine oil consumption by scraping oil from the cylinder walls back to the sump. Again, the main function of piston rings in engines are, number 1, sealing the combustion chamber so that there is minimal loss of gases to the crankcase. Okay? So the word seal, okay? It will not permit the gases, okay, to be lost in the combustion chamber or to go to the crankcase. Okay? Number 2, improving heat transfer from piston to the cylinder wall. Okay? So question, how does the heat will transfer from piston to the cylinder wall? So by means of the piston ring, because the piston rings are attached to the piston, so the piston would transfer the heat to the piston rings, and the piston rings will transfer the heat to the cylinder wall. And as we know, the heat or the excess heat should be drawn out from the engine, okay? From the cylinder wall, the coolant will get the excess heat from the cylinder wall, which comes from the piston, okay? Which is transferred to the piston ring. And the piston rings transfer the heat to the cylinder wall. Understand? Next, maintaining the proper quantity of oil between the piston and cylinder wall. Okay? So the piston rings does not just seal, okay, seal the combustion chamber, but it also maintains the proper quantity of oil between the piston and cylinder wall. Okay? So no oil or excessive oil should be burned during combustion. Okay? And the last one, we have regulating engine oil consumption by scraping from, or rather scraping oil from the cylinder walls back to the sump. Okay? Oil is consumed when it's burned, so how does it regulate? By scraping oil from the cylinder wall, okay? So, from this, we can draw conclusions that the piston ring that I'm showing you right now, these are compression rings. So this seals the combustion chamber. Okay? And the next one, the oil control ring. Okay? It maintains the proper quantity of oil between the piston and cylinder wall and regulates the oil consumption by scraping oil from the cylinder walls back to the sump. Okay, question. Why is there a piston ring and gap clearance? First, let me show you, or let us understand what is a ring gap, okay? So I will show you the ring gap. Okay, so each of these piston rings has a gap. Okay. So this is a ring gap. So when we put it in the cylinder, it will become smaller because it will be compressed there. It is important to have this gap or we have the gap clearance. Why? Because we have two reasons: for good compression and for expansion. Okay? For good compression, so a large gap at the end of the ring makes for an easier leak path. Okay? This means that there is a way for the compressed air to go out if that gap is large. Okay? So if this is large, it's easy for the compressed air to go out or to flow past or to escape onto the combustion chamber, as we have mentioned a while ago. Okay? So you are just making an easy way, okay, for the compressed air to escape from the combustion chamber. Okay? So there must be no large gap, okay, for attaining good compression. Number two, for expansion, okay, heated metals expands. If enough heat is present, the ends of the ring could even touch. As soon as that happens, the ring can no longer accommodate further expansion and begins to tighten in the bore. Okay, so imagine if this becomes bigger, if you have too small gap, and imagine it would touch each other, no more allowance for expansion. So this would touch the cylinder wall and the piston would seize because of this resistance, too much resistance, because it's already tightened in the bore. Okay, so the piston will not anymore move up and down in the cylinder. Okay, so there must be a reason for expansion so that the piston would smoothly run from the upper side and the lower side, or we call it TDC and BDC. Now that we understand things in piston rings, let's proceed to the ring end gap measurement. So how do we measure piston ring end gap? Okay, so we are now here with our engine and we are going to measure the piston ring and gap clearance. Okay, let me demonstrate on how to measure it. First, we will put the piston ring into the cylinder. Okay, as you have observed, I just inserted the piston ring, but it does not sit squarely. Okay, so how to make it sit squarely? You will use a piston, okay, and then you push the piston ring at least an inch, pushing it an inch towards or inside the cylinder, and let a groove or the piston groove be aligned with this with the cylinder block surface. Okay, so the object is to make it straight. Okay, so as you can see, the gap is there. Okay, let me put the camera closer so that you can see the gap. All right. Okay. Now let's proceed on how to measure the gap. So now we are going to use a measuring tool which is called the feeler gauge, and you already know it. I have already taught you this during last semesters subject, tools and measurement devices, I have taught you how to measure the filler gauge. Okay? So in the same manner, you will insert the filler gauge onto that gap. So inside that gap, let's try this 30 millimeter. Okay? We have a 30 millimeter thickness gauge blade. Then we will insert it. Okay? So it does not come in. Okay? So we'll try number 28. Okay? Alright. So now we have attained, or we have, okay, measured the ring end gap. So what's the importance of measuring the end gap? Okay? So let me review it again. We should be sure of the end gap so that there will be no small gap, okay, or a large gap, because there will be reasons the engine will not operate well, because if we have a small gap, the piston rings would cease or would stop working, and if there is a large gap, there would be a compression leakage. Okay, so that's it. That's the important things that you should remember. And for the measurement, for the exact measurement of this, we should consult, or we should refer always to our manual if the measurement is within the specifications. Okay? Now that we have obtained the piston ring and gap clearance, which is 28, or rather 0.28 millimeter, let us convert it to the English system. Okay? So we will use the conversion 25.4 millimeter equals 1 inch. Then we write down 0.28 millimeter equals 0.28 millimeter multiplied by that conversion. So we put 1 inch above as our numerator and 25.4 millimeter the denominator or the divisor. So first we'll cancel the millimeter because it's above and the other one is below. So we'll cancel it out. And then we multiply 0.28 to 1. So the product is 0.28, but the unit will be in the inch unit. And we divide it by 25.4. So we have obtained the answer that 0.28 millimeter is equal to 0.011 inch, or 11 thousandths of an inch. So that ends our lecture for today, and the next topic that will be given will be the valve servicing. Okay? So this is Teacher Lim, your teacher for today. Thank you very much, and have a nice day to all of you.